Today I'm going to be doing LeetCode Weekly Contest 175, and I'll be explaining my solutions after I finish solving all of the problems. Okay, so I just loop through the array. Okay, I'll just calculate the frequency arrays. True. Guess it works. I'll just submit. 150. I guess this works. I'll submit this as well. Accepted. What? Does the frequency even matter? And the time plus 1. Okay, so two tweets. Oh, okay, so for each interval, at most 10,000 operations. N squared might work, I think. Wait, the output has to be N squared, so okay. Make a map of the string. Then I'll store the times. Not exactly sure how I want to do this. I guess. Okay. It's set to 60. This hour it's 3,600 and if it's day, then it's 24 times this. Okay, so I'll find the starting position in well, it's all in the time run. Okay, accepted. This looks like a brute force. Okay, so this is wrong. 2 to 1. This is maximum independent set, and I can write dp plus bitmask. So I don't know why this doesn't work. And I think I'll write a dp with bitmask solution. Zero 60. What? Oh, okay, I see. It's probably because of this. Go to each row. And I'll loop through every bitmask. I should convert the C's to a bitmask first. So wait. The seed is broken, it's this. I see, okay. So if it's this if it's a dot, then we can use it. Accepted, okay. So now make sure this is a subset. have any seats in common, then it won't work. Also need to make sure that, okay, so I'll set this to native infinity at first, and dp00 is equal to 0, and return dpn of, actually, okay, so answer will be 0. Now loop through and calculate the answer. Max. Okay. So now I need to make sure K works. So C side O is broken door. Wait, no, it's okay. So I'll take the it's not okay, then we can continue. Otherwise, dp of I plus 1 k is equal to max of the fourth dp something like this. Six. 4, 3, 10. Why is the output 4? Upper left and upper right? Oh, okay. Okay, then, H is this is upper left, and now I also need upper right. Okay, let's run this. Should be 4, 3, 10. 4, 3, 6. What's column O? Wait, so they can't? Four, 3, 10. Okay, submit this. Hopefully it works. And okay, this time the hard problem is actually a bit harder than usual, so Okay, so I'll go over the problems now. So for this problem, basically, you just have two for loops, one for I, one for j. Then if I and j are both different, then you check if the array, the ith element of the array is equal to 2 times the two times the jth element of the array. And if it is, then we return true. Otherwise, we return false. And this is pretty straightforward. So for this problem, notice that we only care about making the two strings and anagrams of each other. And two strings are anagrams of each other if the frequency arrays of the characters of the string are the same. So actually, we don't care about the order of the characters in the string. We only care about the frequency array of the characters. So basically, in the first part of my code, I calculate the frequency arrays of both S and T. Then to find the answer, basically each time we change one character from one character to another, we can reduce this difference by 2. So for example, if the first string was AB and the second string was BB, then we create a frequency array. A has 1, B has 1, and for the second string, A has 0, B has 2. And then the sum of the absolute differences is just 2. And if we switch from these characters from the B to an A, then we can reduce the absolute difference by 2. So this becomes 0. So it turns out that the answer is just the sum of the absolute differences divided by 2. For this problem, it says that there will be at most 10 to the 4th operations, so I'm not sure if an n-squared algorithm will pass or not. But I think actually you just want to make it so that your time complexity depends on the output of your solution. So then you can make sure that's optimal. So basically I store a map, and then the map will store the times for each tweet. So for the function record tweet, I just look up the map with a key tweet name, and then that gives me the vector, which contains all of the occurrences of this tweet. And then what I do is I use lower bound to find the position to insert the time into, and I insert the time at that position, and that will guarantee that the vector will be sorted after I insert any tweets. And then for the second part, first I convert the string into the number of seconds, which is shown here. Then I retrieve the vector of occurrences from the tweet name. Then I find the position, I find the first position, I find the first element in the vector, which is greater than or equal to start time, and then we start iterating from there. And then, yeah, basically, we go through the intervals until start time is greater than end time. So each time we increase start time by the number of seconds that we determined from the frequency, and then we basically check how many occurrences we check the occurrences which are less than start time, which will give us, and then these occurrences will be the occurrences within the interval, within these intervals. So then for each occurrence that we find, basically add 1 to our answer. And yeah. And then for this problem, okay, so we can do a dynamic programming, which will tell us, and we will do the dynamic programming by rows. So basically, our DP state is, actually, I'll just say it from here. So our DP state ij means that we process the first I rows in our grid, and then the last row we process has the subset j. The subset j of seeds in the last row are selected, and then for the answer, basically just find the DP for the last row over all possible subsets of seeds. And at the start here, basically for each row, I just calculate the mask for the bit mask for which seeds are available. So if a seed j is available, then I basically set bit j to be equal to true in the bit mask. Then in order to transition from from dp ij to dp I plus 1 k, first, this basically makes sure that j is a subset of the seeds which we can choose, and this also makes sure that k is a subset of the seeds you can choose in the next row. So then we need to find if the rows j and k are compatible. So basically there are a few rules here, and the first rule is that if two seeds are left and right of each other and we both choose them, then the students can cheat. So we check if there are any two adjacent seeds that we chose. And when you do that is, so this expression here that I highlighted returns 1 if the nth bit of k is set to 1, and returns 0 if the nth bit of k is not set. And this expression with the XOR 1 basically returns true if the nth bit of k is empty, and returns false if the nth bit of k is not empty. So basically this entire expression means that OK will be equal to true if at least one of these two bits are empty. And that's what we want. So if at least one of the two adjacent seeds are empty, then the condition is satisfied. And then we also do this for j and k because students can see the answers of those sitting to upper left and upper right. So yeah, that's what these two for loops are for. And if everything is okay, then we can transition. So from the previous state, we basically add the number of set bits in k, which is this function built-in pop count. It returns the number of set bits in k, and then we take the max of it with our dp. And yeah, that's pretty much it for this problem. So I don't think I did that well this time. Oh wait, I'm actually third. Okay, I don't think it's that bad. So if you found this video helpful, then be sure to like and subscribe. And yeah, just do it because it's free.